ripple factors. First, I will discuss a full wave rectifier with series inductor filter. All of you know that why the name came as series inductor filter. Any one of you please respond why the name came as series inductor filter.
Inductor is connected in series with load resistance.
Yes, inductor is used as a filtering component and inductor is connected in series with the load resistance. That's why the name came as series inductor filter. Full wave rectifier with series inductor filter. So first I am drawing a full wave rectifier. Let us consider. Here we will use a center taper transformer. Let us consider it is my full wave rectifier. Here I am giving a AC signal from the plug point. A full wave rectifier has center taper transformer. And in full wave rectifier, we will use a two diodes. Let us consider it is a diode D1 and it is a diode D2. In this, we will use a two diodes. And these two are connected together. And here we will take a output. So here we have a resistance, load resistance. Now here full wave rectifier with series inductor filter. So inductor is connected in series with the resistance. So it is a L and it is a RL. It is a D1 and D2. It is a circuit diagram of a full wave rectifier with series inductor filter. All of you know the output waveform of a full wave rectifier. Let us consider what is the difference between the output waveform of a full wave rectifier and half wave rectifier. Output waveform la difference ఏంటమ్మా full wave rectifier ki half wave rectifier ki. In half wave rectifier only
half wave law.
Yes, in half wave rectifier only one half cycle is converted into the positive waveform, whereas in full wave rectifier both positive and negative half cycles are also converted into the positive waveform. So here let us consider it is voltage or current, whatever it may be, current, and it is a time t. So it is a full wave rectifier output without filter. If I am using a series inductor filter, the output waveform becomes, if I am using a series inductor filter like our half wave rectifier only, when our series inductor filter is connected, we are getting a output waveform like this. It is a output waveform of a full wave rectifier with series inductor filter. And the equation for this one is, the equation for that one is I am writing a current equation. I is equal to 2Im by pi minus 4Im by pi sigma. Here k, let us consider k is an even number. And the formula is cos k omega t by k minus 1 into k plus 1. K minus 1 into k plus 1. So it is a equation for output waveform of a full wave rectifier with filter. Now I can write it as a 2Im by pi. And if I am replacing k with even numbers, first I will replace k with a 2. The first even number is a 2. So first I am replacing k with a 2. If I am replacing k with a 2, what is the equation becomes 4 Im by pi into cos k omega t, means in place of a k I will write it cos 2 omega t by 2 minus 1 into 2 plus 1, 2 minus 1 1 into 2 plus 1 2. So finally I am getting 2 plus 1 3, 2 minus 1 1, 2 plus 1 3, 3 into 1 means here I will get a 3. So next, if I am replacing a next even number 4 in place of a k, if I am replacing a even number 4, then the equation becomes 4 Im by pi into cos 4 omega t by k minus 1 means 4 minus 1 3, k plus 1 means 4 plus 1 5, 3 into 5 means it is of 50. So on, it is my equation. Now I want to find the ripple factor. Ripple factor, we can write it as a AC component by DC component, and it is also written as IAC by IDC, VAC by VDC or IAC by IDC. In this output equation, what is the DC value? It is my output equation. What is the DC value in this output equation?
2 Im by pi.
Yes, DC means it is a constant value. Other than this, all are having a coefficient with cosine or sine. So if is there any coefficient with cosine or sine, it is a AC waveform. So only DC waveform is the only DC waveform. So what is a 2 Im by pi? Only the DC waveform. So I am getting IDC equal to 2 Im by pi, and it is also written as 2 Vm by pi into Rn. IDC equal to 2 Im by pi, and it is also written as 2 Vm by pi into Rn. Now, these all are AC components. How I will find a net AC component in a multiple AC components? How I will find a net AC component in a multiple AC components? IAC కావాలనుకోండమ్మా, ఒకవేళ మనకి ఒక 3 కాంపోనెంట్స్ ఉన్నాయి అనుకోండమ్మా, IRMS 1 square plus IRMS 2 square plus IRMS 3 square. Here we have a 3 AC components are there. If we have a 3 AC components there, then we can find a net AC component as IAC equal to IRMS 1 square plus IRMS 2 square plus IRMS 3 square all root over. So in this way we will find a AC component, and we have a here we have a AC components, a lot of AC components with a higher coefficient. So I am taking for simplifying our derivation, so I am taking only one AC component. I am neglecting remaining all AC components. I am considering only one AC component, which is I am considering only one AC component is it. So how I will find IRMS or for any sinusoidal signal? What is the formula for IRMS or IAC? IRMS and IAC and not IAC or IRMS Im by root 2. In this way, we will find a IRMS value of any AC component. What is the maximum value here? What is the maximum value in this equation?
4 Im by 3 pi.
Yes, whatever may be the coefficient of cosine or sine. Cosine, sine కాకుండా coefficient ఏది ఉందో అది మనకి maximum value అవుతుంది. So I am considering only మనకి derivation ఈజీగా అవ్వడానికి I am considering only one AC component. ఈ ఒక AC components నే consider చేసుకుంటాను. So here the Im value is 4 Im by 3 pi, and IAC value becomes 4 Im by 3 pi into root 2. So here I got a IAC value as, here I am writing IAC value, which is a Im, I have Im 4 Im by 3 pi undam. It is a Im value 4 Im by 3 pi, and Im by root 2. For finding a IAC, we have formula Im by root 2, 4 Im by 3 pi. And here I want to write in terms of V. So here I am writing this 4 by 3 root 2 pi. And Im can be written as Vm by RL plus j omega L. But here in place of a omega, we have a 2 omega. In place of a omega, we have a 2 omega. That's why here I can write it as a, actually it is a, we are writing RL plus j omega. In place of omega, here we have a 2 omega. So I can write here RL plus j 2 omega L. And if we are finding a magnitude of this one, how we will find a magnitude of this one means 4 Vm by 3 root pi into RL square plus 4 omega square L square root over. We will find R plus j omega L ante x plus j yn undanukunnam. How we will find a magnitude for this one is root over x square plus y square. In place of x we have a RL, in place of a y we have 2 omega. So R square plus 4 omega L square. And here by comparing it to omega L, we can neglect RL value. Omega L is much greater than RL. So by comparing it to omega L, we can neglect RL value. So what is the equation if we are neglecting RL value? What is the equation here? I am getting 4 Vm 3 root pi into 4 omega square L square root over means 4 omega square L square root over means it is 2 omega L. So I am getting here equation as 4 Vm by 4 means I can write it as a 2 2s. So 2 Vm by it is equal to 2 Vm by 2 2s rational 2 Vm by 3 root 2 pi omega. It is a equation. I got it for IAC. And now I want to find the ripple factor value. మా ఇప్పుడు లంకా అశోక్ ఎవరో జాయిన్ అయ్యారు. టైం ఎంత అవుతుందమ్మా? 11:20. 11 క్లాస్ అయితే 11:20కి వస్తే ఎలా అవుతుంది? So I got a equation for IAC as 2 Vm by 3 root 2 pi omega L. And now I want to find the ripple factor value. It is AC component by DC component. So here I got IAC as 2 Vm by 3 root 2 pi omega L by DC value 2 Vm by pi RL. So here 2 Vm gets cancelled. Pi cancel out of them. So finally I got the equation as RL by 3 root 2 omega L. So what is the value of a 1 by 3 root 2? Anyone please find it by using a calculator. 1 by 3 root 2. One by 3 root 2 value
0.23.
Yes, it is 0.235, right? So 0.235 RL by omega. So it is a ripple factor equation for full wave rectifier with series inductor filter. 0.235 RL by omega. So it is my ripple factor equation for full wave rectifier with inductor.